Over 87% of beginners fail coding interviews because they cannot explain what an array is. And I know this because that was the first question in my coding interviews. But in reality, it's not about the explanation itself, but the students were taught completely wrong. Hi friends, I'm Alex. I'm a senior software engineer who's working since several years on autonomous driving vehicles, hired engineers and sat through real coding interviews, and both as a candidate and as an interviewer. So in this video I will explain you the data structures in a way that I wish somebody has taught it to me, intuitively and visually. And by the end you will finally understand what data structures are, why they exist and why you need to think about them before you even touch one line of lead code. That's crucial, but let's get started. Before we dive deep into arrays and linked lists, one misconception has to die. Data structures is not theory you memorize for your coding interviews. At the core, a data structure is just a way to organize data so certain operations become easier or faster. Every program has data and things it needs to do with that data. But how you organize it decides whether it can be processed fast or slow. Therefore, data structures exist and they are crucial for every coding interview. And before I dive deep, I also want to mention a certain mental model that changed everything for me. Every data structure is a trade-off. Let me explain. You optimize the one thing and then you sacrifice another thing. You optimize for memory and you will lose speed. You optimize for fast access and you will lose flexible insertion. And once you see DSA as a trade-off, it will stop feeling so random to you. Okay, but now let's go a bit deeper. Arrays store values next to each other in a memory. And that's why this operation is more or less instant. But inserting in the middle is quite expensive because every element has to move. So arrays are perfect when the size doesn't change and when you need to read it very fast. Arrays optimize predictable access. As a contrast, we have linked lists. Linked lists don't exist because arrays are bad. It's just for completely different purpose. Elements of a linked list are basically scattered in memory and linked through pointer. So random access is pretty slow, but insertion is cheap. Therefore, the question isn't do you understand what an array is or a linked list? It is actually when do you choose a linked list over an array? I give you 3 seconds. If I should go deeper into other data structures like heap, stack, a queue, please let me know in the comments. But now that we have clarified some basics, how do we use it in interviews actually? And interviewers don't care about memorized definitions. They care if you can explain what operation matters, what trade-off you're actually making, and why it makes sense. And that's why I ask, explain an array to me. And if you can't explain it, the rest will collapse automatically. And therefore I came up with a memorizable framework to make DSA learning quite fast. What data am I storing? What must be fast? What can be slow? And if you take different data types like stacks, queues, heaps, trees, these are all basically just different way to answer these questions. And once you understand it that way, lead code will become way easier and understandable to you. And if this clicked, the next step would be to turn your intuition into an interview skill. And I've actually linked my 8-week preparation plan for coding interview in the description below. It's completely free, so check it out. So learn the thinking first and then solve the problems. That's how I would recommend to do an 8-week preparation. But now that you know that, this video was quite superficial. But I have other videos on my channel. For example, about the video about 3 new ways how to learn DSA, because in today's era with AI and everything, it changes quite a lot how you can learn easier and faster DSA, especially in 2026. So see you in the next video. I would recommend go check it out now. See you there.